This will be an overview of Unit 8. It's the copy of the review and practice test that you're working on at home for homework to get ready for our unit test. Make sure you do step by step and view example when you need help. Question 1 asks us to find equivalent measurements to 0.45 meters or 45 hundredths of a meter. First thing you're going to want to do is you're going to draw your place value chart showing meters. You got king, Henry, doesn't, usually, unit is the meter, drink, chocolate, milk. So I've written in 0.045 meters into that. Now I'm going to convert to each one to see if it checks out. So I'm going from meters here to hectometers here. So it's going to be a double space. So I'm going to shift the decimal point once and twice and fill in my place value holder. So I end up with 0.0045 or 45 ten-thousandths of a hectometer. So that is equivalent to the 45 hundredths meters. For option answer B, we're going to convert it into decameters, and the decameters are right here. So I'm going to take that over. I'm going to move that one place over. So it's 0.045 decameters, and that's what we have there. So that is also correct. For option C, it's 45 centimeters. So let's convert this to centimeters. You got your meters here. You're going over once and twice to centimeters, so it's 45 centimeters, and that also checks out. Let's try D, millimeters. Millimeters is right here, so I'm going to move it over once, twice, 3 times, put my place value there, so it should end up with 450 millimeters, and that is showing me is 0.045 millimeters, so this answer is not equivalent to 45 hundredths meters. Let's go ahead and convert them to kilometers right there. So I'm going to move that decimal point over to the kilometer space and put zeros in there to hold the place value. You can see it's pretty obvious that 45 hundredths meter is not equivalent to 450 kilometers because 45 hundredths of a meter is very small and 450 kilometers would be very large. So that answer does not apply. And the final choice is 45,000 decimeters. I think you can see that that's pretty obvious. You just making it 10 times larger, and that's 4.5. So that also is not applicable. It's not equivalent to 45 hundredths meters. All right, I've already started to unpack this problem by drawing my model. Julian is making barbecue sauce that he will put into jars. He uses 16 cups of tomato sauce, 5 cups of white vinegar, a half a cup of honey, and a half a cup of maple syrup. How many quarts, so we're going to be converting these to quarts, can he fill? And then how many pint jars will be left over? So first thing you have to know, you have to convert from cups to quarts. I know that, I put it right here, quarts, 4 cups is equal to 1 quart. So I'm going to go ahead and convert these measurements above into quarts. Adding all those up, you end up with 22 cups. So how many times will 4 go into 22 cups? Because you are dividing, cups are smaller than quarts, so you're going from a small to a large and you divide. 4 goes into 22 5 times, and there are 2 cups left over. So he can get 5 quarts, and there'll be 2 cups left over. And then going back to review your conversion, 1 pint is equal to 2 cups. So he will be able to have 1 pint left over. Let's unpack this problem, drawing our model. The mass of a science textbook is 1.05 kilograms, and the mass of a history textbook is 850 grams. So if Rami has 4 science textbooks and 5 history books, how much weight of each type of textbook will he have? So we're going to be comparing the masses of these textbooks. I'm going to go ahead, I drew my comparison bar model, 1.05 kilograms times 4 and 850 grams times 5. You do notice that they're giving us kilograms here and they're giving us grams here. So eventually we're going to have to convert those. And since they're asking us to compare the masses in kilograms, we'll convert them to kilograms. So here's my calculations. I did 1.05 kilograms times 4, giving me 4.20 kilograms. 850 grams times 5, giving me 4,250 grams. After I got my grams, I converted that by moving my decimal point over, and I converted that into kilograms. So he had this many kilograms, and he had this many kilograms. So now we can compare the masses of the textbook. So putting these into a comparison bar model, my science textbooks had a total mass of 4.20, and my history textbooks had a total mass of 4.25. So I do know that the mass of the history textbooks is greater than the mass of the science textbooks. And I also know that the difference between the two is 5/100ths of a kilogram. So 4 science textbooks have a mass of 4.05, so that's my mass right there. So that's 420, 4.20, and 5 of those is 4.25, so that's my mass there. So that goes there, and that goes there. And the total difference would be 0.05. Problem 4 has 3 subparts. We're converting milliliters to liters, milliliters to liters, and grams to milligrams. All right, so we'll start with the milliliters to liters. You see that I have 1,200 milliliters, and I'm going to go from milliliters to liters. So I'm going to take that decimal point that exists right there and shift it over 3 times until it gets in between the liters and deciliters. You can see it's 1.2 liters. So my answer for that would be 1.2. Similarly, we're going from 4,000 milliliters, so I'm going to write in my 4,000. I always write it backwards because I always want to start at the place value that it ends with. So 4,000 milliliters, I'm going to change that into liters. Same thing. I'm dividing by 1,000 because there are less bigger units and smaller units, and it ends up with 4. So 4 liters is the same as 4 milliliters. In the third problem, I'm going from grams to milligrams. So let me start with my grams. I have 0.14 grams, and that is the same as, I'm going to convert them to milligrams, 140 milligrams. There are 1,000 milligrams in 1 gram, so there are 140 milligrams in 0.14 grams. Problem 5 is a multi-part problem. You're converting these units over here into their equivalent units of different types. So obviously you're going to convert inches into, you can't change that into cups, you can change that into feet, you can't do it into quarts, you can do inches, you can't do ounces, and you can't do pounds. So the only answers that are going to make sense on that is either changing 78 inches into 6.5 feet or 78 inches into 432 inches. You don't really need to do a whole lot of thinking here because you can't change 78 inches into 432 inches. You are going to change 78 feet into 6.5 feet by dividing 78 by 12. I've gone ahead and done the division here. 78 divided by 12. So 12 goes into 78 6 times. 6 times 12 is 72. 6 left over, so there's 6/12 of a foot left over. And that 6/12 can be simplified into 6.5. So the correct answer is surely 6.5 feet. Second conversion I'm going to work with is 12 3/4 pounds. 12 3/4 pounds is the same as what? So we're either going to be converting to ounces or pounds. The only one that makes sense are the ounces. So I'm going to go ahead and show how you convert ounces to pounds. We're going to here work with that conversion of 16 ounces equals 1 pound. So because there's 16 ounces in 1 pound, we need to find out how many ounces will be 12 3/4 pounds. So I'm going to set up my expression like this: 12 3/4 times 16. A couple ways to do this. You can change this number here into an improper fraction and multiply by 16. But the numbers get really large, so I'm going to go ahead and use a place value section model because I think it's a little bit easier. So to set up my place value section model, you can see right here, I've got 12 times 16, and that's going to be my answer here, and 16 times 3/4, and that's going to be my answer here. You can see I multiplied 12 times 16 and I got 192. So that's the first part of my answer. So I'm going to multiply the second, the fraction portion of my place value section model. 16 wholes times 3/4. So I see right off the bat there's a nice cross cancellation here. So 4 goes into 4 once, and 4 goes into 16 4 times. And 4 times 3 will make 12, and that's 12 wholes. So 3/4 of 16 is 12 wholes. Now I just add these together, and that is my answer. So 192 plus 12 will be 204 ounces. So 12 3/4 pounds turns into 204 ounces. Third part of the problem is going from 17 gallons into another measurement of standard measurement of volume. So it's either going to be 24 cups, 68 quarts. I guess you could convert gallons to liquid fluid ounces, but it's going to be one of those three. So I'm going to be changing. I need to know how many ounces or how many cups are in a gallon. I know that 1 gallon is 128 ounces because I looked it up. And how many cups are in a gallon, I will let you know in a second. So I Googled it, and there are actually 16 cups in 1 gallon. Okay. So right off the bat, knowing that, I know that 17 gallons is not going to equal 24 cups because it would be way too many. So I am confident that my answer is going to be 68 quarts, but I still have to show the math. So how many quarts are in a gallon? 4. So in order to figure this out, I multiply 4 times 17. And sure enough, 17 times 4, 4 times 7 is 28. Regroup the two tens. 4 times 1 plus 2 tens is 6, so it's 68. So 17 gallons is equivalent to 68 quarts. For the next problem, we are converting yards into another form of linear measurement. So yards are not going to equal cups. Yards could be feet. Yards are not going to be quarts. Yards could be inches. Yards are not going to be ounces. And yards aren't going to be pounds. So it's going to be either 6.5 feet or 432 inches. Well, 1 yard is equal to 36 inches. So 12 yards would be 12 times 36. And when I do that math, I'm going to end up with 432 inches. 6.5 feet. 1 yard is 3 feet, so 12 yards will be way more than 6.5 feet. So I really don't have to do the math on that, but if you wanted to, multiply 12 times 36 to get 432 inches. Fifth part of the problem, you're converting 1.5 gallons into another form of volume. So it's not going to be feet, could be quarts, not going to be inches, could be ounces. If they're fluid ounces, it's not going to be pounds. So remember earlier I said that 16 cups is going to equal 1 gallon. So I have a feeling it's going to be 24 cups because 1.5 times 16 is going to equal 3 halves times 16. And if I cross cancel that, 2 goes into 2 once, 2 goes into 16 8 times, 3 times 8 is 24. So the answer is going to be 24 cups. And the final part of this problem, you can kind of do this mentally. A half a ton. Well, if 1 ton is equal to 2,000 pounds, what is a half of a ton? What is 1/2 of 2,000? And obviously 1/2 of 2,000 is 1,000 pounds. So half a ton is the same as 1,000 pounds. All right, cool. We got an easy one. We're going to use the formula to calculate volume of a rectangular prism. Formula for a prism is length times width times height. So we're going to go 11 times 8 times 4 to get our answer. So I do 11 times 8 times 4. 11 times 8 is 88 times 4. I went to place value section model. 4 times 80 is 320, and 4 times 8 is 32. Putting those together, I get 352, and they are cubic inches. Inches cubed. 352 cubic inches. Volume is always measured in cubic units. All right, double part problem here. First thing, they don't give us the dimension for the width A or the height B of these parts of the composite shapes. So we're gonna have to figure those out. So first thing you're gonna do is you look parallel to this. So look parallel to A. I don't see a measurement. 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 I do see a measurement. Any measurement that's parallel is going to be the same. So A has to be 15 meters. Now look for parallel measurements for B. I don't see one. I don't see one. I do see one. That's 10. And I do see one here that is 2. So the difference between 10 and 2 would be 8. So if this is 8 and this is 2, then this has to be 8 and this has to be 8. So B has to be 8 meters. So those are the missing dimensions, 8 here and 15 here. So now we need to deconstruct this and deconstruct the composite shape to make two shapes out of it. I'll do this little tiny box up here. A little tiny box, the formula for that will be 15 by 7 by 2. Okay, and the formula for this box down here will be 25 times 15 times 8. So I'm not going to show you how I multiplied that, but you can go ahead and multiply it. The smaller box on top is 210 meters cubed, and the larger prism on the bottom is 3,000 meters cubed. So you put those two together, you end up with a total volume of this composite shape of 3,210 meters cubed. This question really is just more about identifying attributes of this shape. This is a rectangle. You can tell that these sides are congruent because they show the congruency marks. These sides are congruent because they show the congruency marks. And to right angles, they're all 4 right angles. So you have those. So first one, is it a quadrilateral? Well, yes, it is, because quadrilateral just means 4-sided shape. Is it a rectangle? Yes, by definition. A rectangle is any shape whose opposite sides are parallel and has 4 right angles in it. So yes, it is a rectangle. Is it a square? No, it's not a square, because squares have all 4 sides congruent, and you can see these are not congruent. So no, it is not a square. Is it a parallelogram? Yes, it's a parallelogram because opposite sides are parallel. And when opposite sides are parallel, that is a definition of a parallelogram. Is it a rhombus? No, it's not a rhombus, because a rhombus must have all 4 sides the same. It's like a square or a diamond, but it has to have all 4 sides the same. And so that is not a rhombus. Is it a trapezoid? No, a trapezoid only has 1 pair of parallel sides, and this has 2 pairs, so it's not a trapezoid. These are 2 examples of what a trapezoid would look like. It only has 1 pair of parallel sides. These sides are parallel. These sides here are not parallel. To sum up then, yes, it is a quadrilateral. It is a rectangle. It is not a square. It is a parallelogram. It is not a rhombus, and it's not a trapezoid. Asking us to select an isosceles triangle with a right angle. So remember, by definition, an isosceles triangle is any triangle with 2 or more congruent sides. So these are all isosceles triangles, but they are not all isosceles triangles with a right angle. A right angle is identified by that corner, 90-degree angle where the corners meet. So that's a right angle, and that's a right angle. So of all these, this one does not have a right angle. All these angles are acute. This has an obtuse angle, 2 acute angles. This one has a right angle, but the sides are not congruent. It's a scalene triangle, and this is your right isosceles triangle here. Let's start by unpacking the problem. There's a path that's 65 hundredths meters wide. Mr. Castle extends the width by placing blocks 20 centimeters on each side of the path. So the new path is going to be how many meters wide? So first thing you're going to want to do is you're going to want to draw some sort of model. So here's our path. We know that path is 0.6 0.65 meters wide, and he's going to add 20 centimeters on either side of the path. So they're asking us, what is the total width of the path now? So first thing you're going to do after you understand the problem is you're going to convert centimeters to meters. So this is 20 centimeters here. To change it into meters, I'm going to divide by 100 to give me 0.2. Now remember, he's adding to both sides of the path, so each side is going to have 0.20 meters more on each side. So we add those all up, and we know now that the total width of the path is going to be 1.05 meters. Let's go ahead and unpack this problem because it's a little bit wordy and complicated. The east side of Mrs. Hammond's ranch is 485 meters longer than the west side. So key word there is it's longer than the west side. The west side is 3.8 kilometers long. Two things going on here. One, you've got meters and you've got kilometers. So we're going to need to convert meters into kilometers. So I've drawn my model here. The west side is 3.8 kilometers long. The east side is 485 meters longer than the west side. So I've added on this part right here. We're going to want to convert the 485 meters into kilometers in order to figure out how far that east side is. So I've drawn my place value chart, and I've go ahead and slotted the 485 meters. Now I'm going to change that into kilometers right here. So I'm going to divide that by 1,000. So that's a triple decimal shift to the left, and I get 0.485 kilometers. So now I'm going to add that 0.485 kilometers to the 3.8 kilometers I already have to get the total distance of the east side. So adding those together, I draw my place value columns here and I add them together, and it turns out that the east side is going to be 4.285 or 4 and 285 thousandths kilometers. Spend a minute unpacking this problem. On a 1 mile walking tour of New York City, a group had to take a detour. That's a different route. That was 400 yards than half the distance. Tricky word here, 100 yards shorter than half. So what I've drawn is I've drawn the mile tour right here, and then I have half of that because it's 400 yards shorter than half. So first I have to have half, then I do 400 yards shorter than half, and that, comparing the 400 yards shorter than half, will tell me the answer to the question. Step is to convert the 400 yards into miles into yards, I should say. So there are 1,760 yards in a mile. So that would be 1,760. You take half of that. So half of that would be 880 yards. And then 400 yards shorter than the 880 would be 480. So the detour should be 480 yards long. We're looking for a measurement that's equivalent to 360 centigrams. So again, you have to draw your place value chart. 360 centigrams would be here, and we're converting that into these different forms of measurement. So first we'll convert centigrams into decigrams, and decigrams would be right there. So 360 centigrams is the same as 36 decigrams. I'll rewrite it here. 360 centigrams is the same as how many milligrams? So I'm converting to milligrams, and it is 3,600. So that is also correct. 360 centigrams is the same as how many kilograms? So I got to go all the way over to here. I'm going to be dividing by 10, 20, I'm sorry, 10, 100, 1,000, 10,000, 100,000, a million. So 360 centigrams is the same as 0.000360 kilometers, so that's not the same there. And then finally, 360 centigrams. 360 centigrams, changing that again to kilograms, it is not 3.6 kilograms. So the only answers that seem to be right are A and B. We are being asked to find the volume of a cedar chest that is 34 inches by 26 inches by 22 inches. So I've gone ahead and drawn my dimensions on the prism in order to figure out volume. To calculate volume, multiply the length times the width times the height of the prism. So I multiply 34 by 26 by 22, and I get 19,448 inches cubed. Part 2 of this problem, they're asking, we're going to put a cushion on top of the chest here. So how big does that cushion need to be? We need to calculate the area of this top. And we know that the width is, the length is 34 inches and the width is 26 inches. So we're going to find out the area is equal to length times width. Another word for that would be the base of the prism. So multiplying 34 times 26, you end up with 884 square inches. You have to make sure that it's area, so they're measuring in square inches. And for the final part, they're asking us volume is what? Volume is cubic units. Volume is 3-dimension here, and it is measured in cubic units. Area is 2 dimensions and measured in square units. So this would be cubic units and this would be square units. A door sign has a length of 5 inches and an area of 8 8/9 inches. Use these symbols over here to show an equation that will be used to find the unknown width. So we do know that area equals length times width. So if the length of the door is 5 inches, and the area, the inside space here, is 8 8/9 inches, we don't know the width. So area, which we know, is equal to 5 times some unknown width. If you remember what if you have a variable over here and you want to isolate that variable, you do the inverse operation to get rid of this 5. So 5 times W. If I divide this side by 5, and if I divide this side by 5, I end up with W by itself. Okay? So the equation is now going to be W is going to equal 8 8/9 divided by 5. And that would be equivalent to letter C as an answer. So now we need to solve it. So first thing we want to do is change this mixed number into an improper fraction. 9 times 8 plus 8. Parts times wholes plus parts. So that gives us 9 centimeters. 72 plus 8 is 80. So you end up with 80/9 divided by 5. Now we do the keep, change. This turns into, and we flip that. So it's a keep, change, flip. So it should be 80/9 times 1/5 is an equivalent algorithm for solving this problem. So when you set up the equation like this, you can see that 80 and 5 have a common factor of 5. So I'm going to simplify this by dividing each of these by 5. 5 divided by 5 is 1, and 80 divided by 5 is 16. So we end up with 16/9 times 1 whole, or 16/9. Now 9 goes into 16 one whole time, and there are 7 parts left over. So when I simplify 16/9, I end up with 1 7/9 inches as my width. So I thought I'd just double check my work by doing the inverse operation. So I plug in my answer, which was 1 7/9 times 5, and I solve that equation. 1 7/9 turns into 16/9. 16/9 times 5 is the same as 80/9, and 80/9 simplifies down to 8 8/9 square inches. So this answer was the correct width. A souvenir postcard, which I've drawn for you right here, is 7 1/4 inches long and 2 1/2 inches wide. what is the area of that postcard? Area equals length times width. So I've set up the equation here. I've converted both of these into improper fractions. I don't have any common factors, but so I can't simplify these, so I just have to multiply these across. So 29 fourths times 5 halves is the same as 29 times 5 over 4 times 2. So I multiply these out, I get 145 eighths. Now I have to divide 8 into 145. How many times will 8 go into 145? So 8 goes into 145 18 times, and there is one part left over, so it's 18 and 1/8 would be the area of the postcard, 18 and 1/8 square inches. We're going to be categorizing some of these shapes here based off their attributes. So first off, we want to know if they're either concave, convex, and then are they a hexagon or a pentagon. So first, let's remember what a concave shape is. A cave shape goes inside. You connect 2 points of that shape by going outside of the shape. A convex shape is without an inward. It doesn't go inward. It just is outside. You cannot connect. Two parts of the shape without going inside it. So that's convex, concave. Think of a cave. So the first one, this is definitely a convex shape because it doesn't go inside. And if we count the sides, we count how many sides it has. 1, 2, 3, 4, 5, 6. So it's a 6-sided shape. So that shape would be a hexagon. Second shape, let's look at that. It is definitely concave because it goes inside. You can see right here it goes inside. So that is definitely a concave shape. And how many sides does it have? It has, let's count them, 1, 2, 3, 4, 5, 6. So it also is a 6-sided shape, and that would be a hexagon. So that would be a concave hexagon. This third shape here, it is a convex shape because it does not go inward. No exterior angles point inward, and it is a, how many sides? 1, 2, 3, 4, 5-sided shape. 5-sided shapes are known as pentagons. That goes there. Next shape here is a concave shape because it goes inside, and it is also, let's count the sides, 1, 2, 3, 4, 5, 6, 6-sided shape. That would be a 6-sided shape would be a hexagon, so that would go in this category here. Next shape is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 sides. So that makes it a pentagon, and it has a concave shape, concave angle, an interior angle where I can go outside of it like that. So I'm definitely going into a cave there, and that would make it concave. So I categorize it in the concave section. And the final shape is 1, 2, 3, 4, 5. 5 sides. It makes it a pentagon. And it is definitely convex because it doesn't go inside. So I will just put that shape in the convex category. Right, so we're just identifying which of these shapes, convex, 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 and concave. The others are concave, and you just count the sides. Remember, hexagon is 6, pentagon is 5. Beccari builds this rectangular prism using cubes. What is the volume of this prism? A couple ways we could do is we could count the cubes, we could count the base, multiply by the height, or we could multiply length by width by height. So I'll go 1, 2, 3, 4. It's a 4 by 3 by 3 cube. 4 by 3 is 12. So each floor has 12, and there are 3 floors. So base times height is 36. So that is a 36 cubic unit. There are 12 cubes on the bottom layer, and there are 3 layers, each with 12 cubes, so it would be 12 times 3 to get 36. All right, so we're just asking about some attributes. A circle is a convex polygon. Remember, a circle is not a polygon at all because it has polygons have to have straight sides, and a circle has curved sides. A rhombus can only have one right angle. That's not true because a square is also a rhombus, and a square has 4 right angles. So sometimes a rhombus can have no right angles. Sometimes it can have more than one right angle. All squares are rectangles. That is true. All squares are rectangles because by definition, the only thing you need to have a rectangle is opposite sides are parallel and 4 right angles. And a square has opposite sides parallel and 4 right angles, so it is true. So you got false, false, true. A regular octagon can be concave. Well, by definition, regular octagons all have equal angles. I'm going to try to draw this correctly, but it's not working out too well. All the angles, all the interior angles, and all the side lengths are congruent. So no, a regular octagon cannot be concave because all the angles on the interior would not be congruent. A triangle can have at most one right angle. That is true. There's no way to make a 3-sided shape with more than one right angle. You would never close that shape. A regular triangle has 3 60-degree angles. That is true because all triangles have 180 degrees inside them, and if you divide that by 3, you get 60 degrees for each triangle. So a regular triangle would have 3 60-degree angles. Mika records the number of miles she walks every day. So one day she walked 1.5 miles 5 days. She walked 1 5/8 miles one day, etc. So as you look at the table here, they should match the points plotted on the line plot graph. First question to ask is how many days did she walk total? So to get that answer, you add up all these days here. Add up those numbers there, or you could just count the dots. Either way, you're going to end up with 17 days that she walked. Now, to get the total of miles she walked for, you're going to have to add up all of this data here. So it's going to take a long time, but think about ways to use compatible numbers to help you. An example of compatible numbers is, let's just start working on the first group here. She walks 1.5 miles 5 times. So we could just count 1, 2, 3, 4, 5, and then a half 5 more times. So that'd be 5 halves. And you could simplify that down to 2.5 plus 5. So for this first day, she would walk 7.5 miles. So I just went ahead and multiplied the numbers times how many times she walked it, and I come up with these products here: 7.5, 1 5/8, 2 6/4, 4, 6 3/8, and 8 4/4. I did not simplify these yet into mixed numbers. One way to do it is just to find a common denominator between all of these fractions here. So I came up with eighths, and I changed them all into eighths. So a half is equal to 4/8, 5/8 is 5/8, 6/4 is 12/8, 3/8 is 3/8, and 4/4 is 8/8. So I have all these numbers here, and I'm just going to go ahead and add up all my eighths. So when I add up all my eighths, I end up with 32 eighths and 28 wholes. And I can modify 32 eighths. I can convert that. 32 goes into 8 goes into 32 4 times, so that's 4 more wholes. And so I have 28 plus 4, which would be 32 miles that she walks. Choose a term from the box to complete the statement. Every rectangle is also what? Well, every rectangle, if you draw a rectangle, opposite sides are parallel. So every rectangle is also always a parallelogram. It's not always a square. Sometimes a square can be a rectangle, and sometimes a rhombus can be a rectangle if it's a square. But always a rectangle is a parallelogram. And the final question, choose a term to complete the statement. A trapezoid is also a what? Well, a trapezoid is not a parallelogram because only one pair of sides is parallel, and parallelogram is both sets of sides are parallel, so it's not. It's not a rhombus. It could be a rhombus. I mean, no, it's not a rhombus um, uh, because a rhombus has both sides parallel, but a trapezoid is always a quadrilateral. Any trapezoid, no matter how you draw it, it always has four sides. So trapezoids are always quadrilaterals. Woohoo! That's it. It was a lot of work. Go ahead and do the practice Think Central test online to get ready for this test, and you'll do great.